we learn about the similarity of triangles. Here, we have two triangles, ABC and PQR. Can you name the corresponding angles of these triangles? Absolutely correct. Here, angles ABC and PQR, angles BCA and QRP, and angles CAB and RPQ are the corresponding angles. When we observe the triangles ABC and PQR, we notice that their corresponding angles are equal and their corresponding sides are proportional. In the previous video, we learned that two polygons are similar if their corresponding angles are equal and their corresponding sides are proportional. Hence, these two triangles will be similar. We represent the similarity between two polygons by this symbol. Famous mathematician Thales has given a conclusion by using the basic proportionality theorem that the ratio of any two corresponding sides in two equiangular triangles is always the same. Can you tell what are equiangular triangles? Triangles which have equal corresponding angles are called equiangular triangles. Now let's understand the basic proportionality theorem with an activity. Let's take a triangle-shaped piece of paper. Let's call it ABC. When we measure the sides of this triangle, we find that AB is equal to 14 centimeters, BC is equal to 35 centimeters, and AC is equal to 21 centimeters. Now let's take a point T anywhere on the triangle. And we draw a line parallel to line BC through the point T, which cuts the sides AB and AC at points M and N respectively. And point M divides the side AB into two parts AM and MB. And point N divides the side AC into two parts AN and NC. As you can see, here we get a new triangle AMN. If we measure the sides of triangle AMN, AM measures 6 centimeters, AN measures 9, and MN measures 15 centimeters. Can you comment on the sides AB and AC? Can you find the length of sides MB and NC? This can be done with the help of a scale, or in this manner as well. If you pay attention, you will find that AMMB and ANNC are mutually proportional. Based on this activity, we can say that if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points, these two sides are divided in the same ratio. And this is known as the basic proportionality theorem. Can you test the converse of this theorem? Will this also be true? If a line divides any two sides of the triangle in the same ratio, then this line is parallel to the third side of the triangle. Theorem. Today, we will look at some interesting examples based on it. Nakul was standing below a pole built in his school. The length of his shadow was 4 feet, and the length of the shadow of the pole was 7 feet. He sees that the lines connecting the ends of the two shadows at their maximum heights were parallel to each other. If the height of Nakul is 5 feet, then find the height of the pole. Can you find this? You may think that it is not possible to do this without a ladder and a scale. But solving this and such similar questions becomes easy with the help of basic proportionality theorem. If you observe carefully, you will notice two triangles, ABC and DBE here, in which AC and DE are parallel to each other, where AC and DE are the lines connecting the ends of the shadows of knuckle and the pole to their maximum height. We assume that the height of the pole to be x, which we have to find out. BE is the height of knuckle, BC is the height of the pole, DB is the shadow of knuckle, and AB is the shadow of the pole. Looking at this picture, we can say that line DE intersects the sides AB and BC of the triangle ABC at points D and E respectively, which is parallel to the third side AC of triangle ABC. Can you find the value of x? For this, we can use the basic proportionality theorem, according to which if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. In this triangle, sides AC and DE are parallel. Hence, the ratio of BE and EC would be equal to the ratio of BD and DA. Now, we substitute all the values. Can you now think of a method to find the value of DA? You can find the value of DA as follows. Substituting this value of dA, we get x is equal to 8.75. Therefore, the height of the pole would be 8.75 feet. In this example, you saw how we can use the basic proportionality theorem in our day-to-day life as well. Let's look at another example. With the help of this figure, prove that in triangle XYZ, lines YZ and MP are parallel to each other. What can you tell by looking at the figure? The similar arrow marks in the figure indicate that these lines are mutually parallel. We have been asked to prove that the lines YZ and MP are parallel. How can we prove this? If we observe the triangle XOY, we get to know that the line MN is parallel to the line YO. Hence, according to the basic proportionality theorem, XM by MY equals XN by NO, which is represented by equation 1. Similarly, we can derive equation 2 from the triangle XOZ. From equation 1 and 2, we get XM by MY equals XP by PZ, which we represent by equation 3. Now if we look at triangle XYZ, with the help of equation 3, we can say that the line MP divides the sides XY and XZ in the same ratio. Hence, according to the converse of basic proportionality theorem, we can say lines MP and YZ are parallel to each other. In this video, we'll look at one more example on similarity of triangles. Find the value of A in the triangle XYZ. To solve this question, pause this video and match your answer. How can we find the value of A? You can see that the line PQ divides the sides XZ and YZ into two parts. The arrow marks here show that lines XY and PQ are parallel lines. Hence, according to the basic proportionality theorem, we can say that in triangle XYZ, XP, PZ and YQ, QZ will be proportional. Can you guess the next step? In the figure, we can see that xp is equal to a plus 3, pz is equal to 3a plus 19, yq is equal to a, and qz is equal to 3a plus 4. On cross-multiplying and solving, we get a is equal to 2.